Okay, a very good evening to one and all. Hope my screen is visible and I am audible to everyone. Please let me know in the chat box if it is so. Quickly. My screen visible, I am audible to everyone. Okay. So we have discussed till question number 90, I guess, and today we will be starting with question number 91. So let's have a look. And this question is directly from the lines of your ecology textbook, where we have talked about that incoming solar radiation, that what is the amount which is being there for photosynthesis, and where I talk about that ISR and PAR. So it says that, question says that, question number 91 says that the radiation pertaining to wavelength suitable for photosynthesis is about. So there in that literature, we have already written that half of the incoming solar radiation is only useful. Half is either reflected or not absorbed or not reaching to the surface or deflected. But 50% of the incident solar radiation is there, which can be used for photosynthetic purpose. So near about 50%, one of the option is there. So that's why we can keep independent selection of 44% of incident shortwave radiation or incident solar radiation, which is basically coming from the earth, from the sun, right? So that is the same ISR, incident solar radiation, which I talked in ecology. So this question have been taken from that line only, that ISR, where we said that it is 50% of the total radiation, which can be out of this 50% of this can be utilized. So 50% of this is utilized for the purpose, and 44% is the near about option. So correct option is one only. And then we can explain this with the help of suitable literature, which have been attached, that why we chosen this, right? So why the first was correct answer, you can see the supporting stuff, right? Yeah. So as you can see about the PAR, that photosynthetically active radiation PAR, which is 400 to 700 nanometer as per the literature. So photosynthetically active radiation, photosynthesis is the process by which the plant convert the light into the chemical energy, and not all the wavelength of light are equally effective for photosynthesis. The specific range of electromagnetic spectrum that photosynthetic organisms are able to use in this process of photosynthesis is called photosynthetically active radiation, which we call as PAR, right? Okay. Then wavelength range PAR typically span the visible light spectrum through 400 to 700 nanometers, right? Include green, blue, green, yellow, orange, and red light. Solar spectrum, when we talk about the sun emit radiation across wide spectrum, including UV, visible, and IR. And the last portion is with the answer, right? Okay. So last portion with the answer, which says that proportion of solar radiation, the visible light spectrum, 4 to 700 nanometer, continuous approximately 45 to 50% of total incident shortwave radiation, which I told you that ISR. So reaching to the Earth's surface, and the exact percentage can vary slightly depending upon the atmospheric condition, cloud aerosol, and the sun. So if you go to nearby option, then it basically 44% of ISR. That is the correct answer. That's why we have chosen first as a choice in this question. So this was not a tough question at all, right? Rest of the options are not even near about. So that's why the correct answer for 91 is first. Is that clear to each and everyone? ये उन्हीं लाइनों में से है, क्योंकि इकोलॉजी मैंने पढ़ाया, तो मैं आपको बता सकता हूँ कि एग्जैक्टली वो लाइन है जहां पे आपने कैलकुलेशन सीखी थी, दैट R इज इक्वल टू 2 टाइम्स ऑफ द ISR, राइट? आप जाके विजिट भी कर सकते हैं, बुकलेट में भी है ना? पेज नंबर भी वी कैन टेल यू कि बुकलेट में किस पेज पे ऐसा लिखा है कि 50% ऑफ इंसिडेंट सोलर रेडिएशन ये होता है। तो एग्जैक्टली पेज नंबर भी मैं आपको बता सकता हूँ, विच इज पेज नंबर 7 ऑफ बुकलेट 2, जहाँ पे क्लियरली लिखा है ओनली 1 to 5% ऑफ टोटल 50% ऑफ द ISR इज कैप्चर्ड बाय प्लांट, और वी कैन से 50% ऑफ द पार इज अवेलेबल। तो ये सेम ही लाइन है गाइस, राइट? तो ये आपको ध्यान रखना है। तो लिखा भी हुआ है 50% ऑफ टोटल ISR इज विजिबल लाइट विच इज अवेलेबल फॉर प्रोड्यूसर फॉर एब्जॉर्प्शन एंड फोटोसिंथेसिस। तो ये चीजें आपको याद होनी चाहिए कि ये वहां से मेरी बुकलेट में पिक हो रहा है क्वेश्चन। बट एनीवेज, let's move to the next question, which is question number 92. It is also a repeated question of multiple times where we talk about in situ bioremediation and ex situ bioremediation. Before we move to this question, we should also know about the bioremediation. So whenever you use any plant or its part or microbe or animal for the remediation of the soil or any other stuff, right, or degrading any other pollutant, it is called bioremediation. ये बुकलेट 3 में बड़े अच्छे से लिखा हुआ है कलर में, और कई बार मल्टीपल टाइम्स पे क्वेश्चन भी आया हुआ है। तो दो तरह का बायोरेमेडिएशन होता है गाइस, इन सीटू और एक्स सीटू। इन सीटू मतलब ऑन साइट। So when you talk about on-site bioremediation, so we should keep in mind, so in situ bioremediation methods is in situ bioremediation refers to the treatment of contaminated soil or groundwater at the site without excavation or removal. And this approach uses microorganisms to degrade the environmental pollutant directly in the place they are found. And common in situ methods are कौन कौन से? बायोवेंटिंग है, बायोस्पैरेजिंग है, बायो ऑगुमेंटेशन है, नेचुरल टेनुएशन है, बायोस्टिमुलेशन है, फाइटो रेमेडिएशन है। ये सारे के सारे इन सीटू है, बट एक्चुअली इट इज देयर, यू कैन सी दैट व्हाट बायोवेंटिंग इज, right? What bioventing is. So whenever you supply air or oxygen to contaminated soil, that is called bioventing. Similarly, biosparging, everything we have explained, but these are the methods which falls under in situ, right? Then comes ex situ, जब उस साइड से आप सॉइल या वाटर को निकाल के देन यू प्योरीफाई, तो ex situ में आपके ये सारे मेथड आते हैं, ठीक है? यू कैन सी हियर that ex situ remediation methods, bioremediation involve the removal of contaminated soil, sediments or water from the original location of treatment. And this method offers more control over environmental condition, that is temperature, moisture and nutrient levels, and can accelerate the remediation process, right? So as far as the common ex situ methods of remediation is concerned, land farming is one of them, composting another of them, biopiles or biocells, slurry phase bioreactor, soil washing followed by biotreatment, and a biofilter is also a ex situ remediation method। ये आपको ध्यान रखना है, ये सारे ex situ में आते हैं। तो क्वेश्चन की चॉइस बड़ी सिंपल थी, राइट, है ना? बायोफिल्टर्स को भी आप देख लेंगे तो 6 नंबर ऑप्शन है, इसके एडवांटेजेस क्या है, डिसएडवांटेजेस क्या है, राइट, है ना, XC2 में। तो यहाँ पे सिंपल सा क्वेश्चन पूछा था आपसे कि विच ऑफ द फॉलोइंग इज नॉट एन XC2। तो आपको दिख रहा है बायोवेंटिंग जो है वो तो आपका लैंड फार्मिंग इज 1 बाय 1 चलते हैं। बायोरिएक्टर XC2, जस्ट बायोरिएक्टर इन XC2 मैंने मेंशन कर दिया है। बायोफिल्टर XC2, right? Land farming XC2, but bioventing which have been mentioned here, there is a in situ method, ठीक है, in situ है, तो इसमें odd one out, क्योंकि पूछा है not an XC2 method, so not an XC2 method is bioventing because it is a in situ method, right? Just a minute guys. Guys, just give me 2 minutes. I will be back. So correct answer here will be bioventing because I have to do a mail. I got an urgent call. So bioventing here is the correct answer. Bioventing is the correct answer, right? Just give me 2 seconds. Okay, sorry for the interruption, guys. I guess everyone is here. So the correct answer for this question 92 is bioventing. I told you that because bioventing is a in situ method. So that's why bioventing is the correct answer. Right, rest all are ex situ. Is this thing clear to each and everyone? जल्दी से बताइए फटाफट. क्लियर है? सबको क्लियर है गाइस? क्वेश्चन नंबर 92 जल्दी बताइएगा. चलिए आगे चलते हैं हम. लॉस्ट सम टाइम इन बिटवीन. अब देखिए ये क्वेश्चन भी डायरेक्टली बुकलेट से है आपकी. और जब हम इनरिचमेंट ऑफ न्यूक्लियर ओर पढ़ाते हैं तो ये बुकलेट में दिया हुआ है कि यूरेनियम 238 जो है वो फीजिबल मटेरियल नहीं है, फिसाइल मटेरियल नहीं है, U35 है. तो ये आपको ध्यान रखना है कि U235 जो है इसमें कॉन्सेंट्रेशन पूछा हुआ है इन द इंक्रीजिंग ऑर्डर. तो बड़ा आसान सा क्वेश्चन है, इजी क्वेश्चन है. और ये इनरिचमेंट ऑफ यूरेनियम जो हर बार पढ़ाया जाता है उसी से आया हुआ है. When we talk about question number 93, it is a very simplistic question. It says that identify the correct sequence of concentration in increasing order. Right? Identify the correct sequence of concentration in increasing order of the following uranium isotope in naturally occurring uranium. अब जब नेचुरली अकरिंग यूरेनियम की आप बात करते हैं तो जब आपको ये दिखेगा कि एग्जिस्टेंस की बात है, तो जब हमने इनरिचमेंट की बात करी थी हम रिवर्स कन्वर्जन करते हैं. हम 238 से 235 में कन्वर्ट करते हैं. तो सबसे ज्यादा तो ये पता ही है कि 238 में होता है. 238 में करीबन 99.27% के आसपास होता है जो कंसंट्रेशन है यूरेनियम का. तो विच हैव बीन मेंशन हियर, लाइक यू कैन सी हियर that in uranium 238 we have almost 99.27% फर्टाइल होता है ये, लेकिन फिजाइल नहीं होता. बट इसको इजीली आप प्लूटोनियम में कन्वर्ट कर सकते हैं. उसके बाद बारी आती है जिसमें हम कन्वर्ट करते हैं, इनरिच करते हैं, वो यूरेनियम 235 में इनरिच करते हैं. तो उसमें हम जब कंसेंट्रेशन डालते हैं तो 0.72 के आसपास होती है नेचुरली. ठीक है. और 238 को हम 235 में कन्वर्ट कराते हैं कि जितना अच्छा हो जाए, 1% 2%. तो तीन कैटेगरी है वहां पे: हाई इनरिच यूरेनियम, लो इनरिच यूरेनियम, मॉडरेटली इनरिच यूरेनियम. अगर आपको याद आ रहा हो लास्ट टाइम भी मेरा सेशन था इस पे. ठीक है. तो क्लाउड पे है भी लेक्चर दिसंबर वाले में पूरे इसके. तो वहां पे जो तीन कैटेगरी है तो उसमें क्या है कि सबसे पहले हम स्टार्टिंग कर रहे हैं 238 से, 235 में कन्वर्ट करते हैं. यूरेनियम 234 जो है बहुत ट्रेस अमाउंट में मिलता है एनवायरमेंट के अंदर, विच इज अराउंड 0.0055. और यूरेनियम 233 प्रैक्टिकली जीरो होता है, नेचुरली अकरिंग है ही नहीं है. ठीक है. आप वैसे भले ही बना लें आर्टिफिशियली, पर ये नेचुरली अकरिंग आइसोटोप नहीं है. 234 5 38 ही नेचुरली है. उस पर भी 38 और 35 भी मेजरली चलते हैं. आपके जो दो आइसोटोप है जिनकी हम बात करते हैं कि 35 जो है वो न्यूक्लियर फ्यूजन शो करता है, 38 शो नहीं करता. तो यहाँ से देख के मुझे पता चल गया सबसे ज्यादा कंसंट्रेशन तो 38 में है भाई. उससे ज्यादा तो किसी में है ही नहीं. उसके बाद 35 की बारी है. तो ये तो बहुत ही सिंपल क्वेश्चन था. मतलब 38 से इसमें सबसे ज्यादा हो तो डी सबसे ज्यादा हो. डी सबसे ज्यादा एक ही ऑप्शन में है बॉस. डी सबसे ज्यादा एक ही ऑप्शन में है. ठीक है. डी सबसे ज्यादा एक ही ऑप्शन में है तो फर्स्ट ऑप्शन करेक्ट आंसर होगा. परसेंटेज वाइज भी अगर आप देखेंगे तो यू कैन इवेल्युएट कि जो अगर मैं परसेंटेज वाइज भी लिख दूं, 38 में आपका करीबन करीबन 99.27 है नेचुरली अबंडेंस. ठीक है. 35 की बात करूं तो 0.72 है परसेंट. ठीक है. 34 की बात करूं तो 0.005 है. और 33 तो है ही नहीं, जीरो के आसपास है. सबसे कम 33 है. तो ए सबसे कम और डी सबसे ज्यादा. तो ऑर्डर आपको दिख ही गया है. फर्स्ट इज द करेक्ट आंसर फॉर क्वेश्चन नंबर 93. फर्स्ट करेक्ट आंसर हो जाएगा. और ऑप्शन आपको दिख ही गया है. द करेक्ट आंसर इज A B C D. डी में सबसे ज्यादा है. तो करेक्ट आंसर आपका यही हो जाएगा जो फर्स्ट है। क्लियर है सबको? जल्दी बताइए। किसी को कोई डाउट है यहाँ तक? जल्दी बताइए। Anyone having any doubt till here? So you should know the language also that how, ये सिंपल डायरेक्ट बुकलेट से है जहां पे मेंशन हुआ है कि ठीक है जी। तो ये ध्यान रखिए। आगे चलते हैं नेक्स्ट क्वेश्चन पे। हम नेक्स्ट क्वेश्चन इज क्वेश्चन नंबर 94। भाई इसको क्वेश्चन को तो मैं 12th क्लास का क्वेश्चन कहूंगा, क्योंकि ये क्वेश्चन यहाँ से तो लिया नहीं इन्होंने। ये तो डायरेक्टली देखा जाए तो 12th क्लास का क्वेश्चन है या 11th 12th का क्वेश्चन है, जब थर्मोडायनेमिक्स पढ़ाया जाता है 11th वाले बच्चों को फिजिक्स में। तो ये कॉन्सेप्ट आता है हमारा हीट कैपेसिटी का, राइट। पर हम इसको देख लेते हैं, कोई दिक्कत वाली बात नहीं है। ये आपका जीएस टाइप का क्वेश्चन है, आपकी नॉलेज को भी बढ़ाएगा, राइट। तो इस पर कोई टेंशन लेने वाली बात नहीं है। लेट्स टॉक अबाउट क्वेश्चन नंबर 94 व्हाट इट सेज। तो यहाँ पे स्पेसिफिक हीट के बारे में पूछा, अलग अलग सब्सटेंसेस की ना, कि हीट कैपेसिटी क्या होती है, राइट। हीट कैपेसिटी की अगर बात करें तो हीट कैपेसिटी अलग अलग सब्सटेंस की है, तो हम देख लेते हैं कितनी कितनी होती है हीट कैपेसिटी। तो पहले तो आपको ये जानना पड़ेगा हीट कैपेसिटी होती क्या है गाइस। हीट कैपेसिटी इज द अमाउंट ऑफ हीट एनर्जी रिक्वायर्ड टू रेज द टेम्परेचर ऑफ ए सब्सटेंस बाय 1 डिग्री सेल्सियस और 1 केल्विन। तो कितना अमाउंट ऑफ एनर्जी आपको रिक्वायर्ड होता है किसी भी सब्सटेंस का टेम्परेचर टू रेज बाय 1 डिग्री सेल्सियस, एंड द फार्मूला अप्लाई हियर इज which I talked yesterday also in OTEC, that is Q is equal to MC delta T। जो हम बात करते हैं ना, that heat is equal to M into C, which is specific heat capacity into delta T, which is change in temperature। ये फार्मूले के बेसिस पे we calculate the heat capacity, right? We calculate the heat capacity, that Q is equal to MC delta T, where M is the mass of water, C is the heat, specific heat, and delta T is the change in temperature, right? So then you can see it have been mentioned like it is an extensive property, means it do not depends upon the amount of substance, depend upon the path follow. The specific heat capacity refers to the heat capacity per unit mass, and unit is joule per degree Celsius or joule per Kelvin. So now if we arrange the substance by increasing heat capacity at standard temperature and pressure, so you can see the example that which are having what. List is very long. So you can see here that some of the examples which we should know, that if you talk about air, it is having 1 joule per gram per degree Celsius, right? Your 1 joule per degree Celsius. Then water 4.18, right? Around, right? 1 कैलोरी के आसपास ही होती है। तो उसके बाद then ice is 2.10 and dry sand is 0.20। ये इनकी स्टैंडर्ड वैल्यूज है। तो इफ यू नो द वैल्यूज, मतलब ये इट्स लाइक अ फैक्चुअल क्वेश्चन, इफ यू नो द वैल्यू फॉर एयर एंड वाटर द स्पेसिफिक हीट, ये तो हमें पता है कि वाटर की सबसे ज्यादा होती है, राइट, अमंग दीज, राइट। और एयर की यूनिटी होती है, ये 11th 12th में सब याद रखते हैं। बट इफ यू रिमेंबर दैट थिंग, then you can arrange that water is having maximum, then ice which is in between and which is a form of water only, then air, and then dry sand. So this is the order of increasing heat capacity. So you can have some knowledge regarding this, because why dry sand is least, because it has a very low heat capacity, it heats up and cool very quickly. Air has moderate heat capacity, it takes longer and longer to change the temperature than sand. And then we have ice, which is solid water, has a higher heat capacity than air or sand, but less than liquid water. And then you have the water, has the highest specific heat capacity among the common substance. It resists the temperature change effectively, and that is why it is used widely in thermal regulation। इसीलिए हम इसको यूज करते हैं, क्योंकि स्पेसिफिक हीट कैपेसिटी ज्यादा होती है। पहले भी एक क्वेश्चन आया था हीट कैपेसिटी के ऊपर कि बॉईल कर जाता है या वेपर बन जाते हैं, उसके पीछे क्या रिस्पॉन्सिबल है। तो वो हीट कैपेसिटी का ही लॉजिक था, एंड द करेक्ट आंसर हियर विल बी 3, because water is maximum, followed by ice, followed by air, followed by dry ice. So the correct answer here will be 3. Clear? Is that clear to each and everyone? Question number 94. Quickly, guys. Question number 94 is clear to each and everyone. Yeah, so keep the logic in mind why we are doing so. That is mandatory. Okay, now let's move to question number 95. We have attached everything, is just taking down the logic, right? This question is repeated multiple times. It's a question. हाँ, इसका लॉजिक ये है, मैं बता रहा हूँ, क्योंकि हमें मोस्ट अप्रोप्रिएट चूज करना पड़ता है, तो मोस्ट अप्रोप्रिएट थर्ड ही बैठ रहा है उसके हिसाब से। अगर आप देखेंगे ना, मोस्ट अप्रोप्रिएट में थर्ड ही बैठ रहा है। डाटा को मैं ये नहीं कह रहा कि डाटा की बात है, ठीक है ना। नहीं, 3 4 में कंफ्यूज क्यों होना है? वाई यू शुड कंफ्यूज इन 3 4? भाई ड्राई सैंड का 0.2 है, तो एयर तो उससे आगे ही है ना, ठीक है। मैं ये आपकी बात को मान रहा हूं। आप उसको हटा दीजिए बीच में से, डी को। अगर आपको सीक्वेंस में अरेंज करना पड़ेगा, आप डी को हटा दीजिए। बी ए सी ये ऑर्डर होना चाहिए। आई एग्री विद दैट, आई एग्री विद दैट। ड्राई सैंड का कम है, उसको एयर से पीछे जाना चाहिए। लेकिन मेरे पास, मुझसे क्वेश्चन में पूछता क्या है? मुझसे क्वेश्चन में पूछता है मोस्ट अप्रोप्रिएट। तो मोस्ट अप्रोप्रिएट के हिसाब से बी शुड बी फॉलोड बाय ए, देन आई हैव ओनली वन ऑप्शन। तो मुझे मोस्ट अप्रोप्रिएट को देखना है, ठीक है। आई एग्री कि ड्राई सैंड का पीछे होना चाहिए था, डी शुड बी बिहाइंड सी। बट आपको एग्जाम में बोलता है चूज द मोस्ट अप्रोप्रिएट ऑप्शन, तो कई बार आपको ऐसा ऑप्शन मिलेगा। यू शुड नॉट लुक इट, क्योंकि 3 ट्रेंड ठीक बैठ रहे हैं, ओनली वन ट्रेंड इज मिसलीडिंग, राइट। तो उन्होंने ड्रॉप नहीं किया, इसका मतलब दे आर एक्सपेक्टिंग कि भैया इनमें से कौन अच्छा है उसको चूज कर लो, राइट। So now let's go to the next question, which is very easy question, multiple times have been asked in grid ecology evolution, right? And if you talk about this Shannon Weaver diversity index, जो मैंने उस दिन भी बताया था आपको, Shannon Weaver diversity index, कि Shannon Weaver index जो है एक पैरामीटर होता है for the measurement of diversity. So let's talk about this Shannon Weaver index a bit, so that we can come to the question and digest it very well, right? What it is actually. So when you talk about Shannon-Weaver diversity index or Shannon diversity index H dash, the Shannon-Weaver diversity index is a commonly used metric in ecology to quantify the species diversity within a community, and it considers two main components. Only two components mainly it considers while calculations, right? In gate ecology evolution, every time the question comes over this. Species richness, they take the number of species. This refers to total number of different species present in a community, and all else being equal, a community with more species will have higher Shannon-Weaver index. And the second thing which you should know is species evenness, which is equitability, right? Evenness hai ki nahi hai. This refers to how close in number each species is within an ecosystem, and if all the species have similar abundance, the community is considered even. And if some species are very abundant with other very rare, the community is uneven, means whether it is equally distributed or not. A more even distribution of individual among species will result in higher Shannon-Weaver index. So the formula is that H dash is equal to summation of I varying from 1 to S, Pi ln Pi, right? So this formula is for Shannon-Weaver index. And then you can see what H dash is, Shannon-Weaver diversity index. S is total number of species in the community, which is species richness. And Pi is the proportion of individual belonging to ith species. So those things you can see, right? So let's analyze the options that which are there. So if you see that only two things they have mentioned species evenness and richness. So only two things they pick up. They talk about species evenness and they talk about richness. So richness of all the species and equitability is the only factor which they consider under Shannon-Weaver index. The rest all not. We have mentioned that. So third is the correct option here, because they consider only species richness and species evenness, which is equitability. So these two options are a part of calculation of Shannon-Weaver index. Rest are not. So rest will be eliminated. Richness of only endemic species, no. Richness of only invasive, no. Genetic diversity is no. So richness of all the species and equitability, right? We could have think of genetic diversity if it would have been in option with ADE, but ADE is no option. So the correct answer here is third. Is this thing clear to each and everyone? Because we have to choose most appropriate. Question number 95. Correct option is 3 only. Right. So in exam, you have to choose the most appropriate. Nobody is going to ask you that there is one defect in this option, but you can say the cross argument, it is the most appropriate option among the given. Right. They are concerned about the most appropriate. Right. They are not concerned about anything else. They are concerned about the most appropriate. Then let's coming next. Yeah, this is a repeated question of n number of time. Frankly speaking, n number of time this question is repeated. That's why I say you should read solutions. क्वेश्चन नंबर 96, जिन्होंने भी सोल्यूशन पढ़े हैं पहले उनको पता है ये क्वेश्चन कम से कम भी 5 बार रिपीट हो चुका है आज तक की हिस्ट्री में. लास्ट सेमेस्टर में भी इट वाज देयर, this semester it was there, and before that it have 2-3 times topple up here and there, but the lines are directly written into your booklet, so you need not to worry, you could have catch it directly. The intensity of solar radiation reaching at the top of the atmosphere of Earth is maximum, means at 500 nanometers. So 500 nanometer is the maxima of PAR because it is the center point of 400 to 700 nanometer, which is sun's radiation. Sun's PAR's maxima, which is 500. We have talked about this, right? So the intensity of solar radiation reaching at the top of the atmosphere of Earth is maximum. So यहीं से आपको माइंड में आना था, they are talking about lambda max. 500 nanometer बोल दिया ना. 500 nanometer is the lambda max for the visible light. 400 to 700 के बीच में एवरेज कितना आएगा मैक्सिमम 550, which is around 500 nanometer, which is the green light. So they have said maximum lambda. So this have given a hint that lambda max is equal to 2897 divided by temperature in Kelvin. This expression everyone knows. This belongs to Wien's displacement law. Nobody can deny that. This law basically belongs to Wien's displacement law. So that's why the correct answer here is Wien's displacement law without any doubt. Right. So Wien's displacement law is the correct answer for this question. And the hint was given that 500 nanometer is the lambda max. So lambda max is stopped only in that. And rest of the laws you know very well. We could have a look because once again the questions can come like Wien's displacement law explain the relationship between temperature of the black body like sun and the wavelength at which it is emitted. Formula is in front of you, right? So they have shown the cross calculation also how it came out to be 500 nanometer, taking the temperature of sun to be 5778 Kelvin, right? And Wien's constant, right? So it's easy, right? So you can calculate that. Lambda max is the peak wavelength, right? T is the temperature in Kelvin, and then Wien's constant is there. So sun's wavelength was a hint here. Then the second one is that like now they have mentioned that this explains why intensity of solar radiation peaks near 500 nanometer visible green blue region. Then we have the Stephen-Boltzmann law, which is E is equal to sigma t raised to the power 4. Total energy emitted per unit area of the black body is the fourth power of temperature. E is equal to sigma t power 4, where E is the energy emitted per unit area, sigma is the Stephen-Boltzmann constant, and T is the temperature in Kelvin. All the things are written there. Kirchhoff's law of thermal radiation, it basically states what? It states that good absorber is also a good emitter. This question have been asked 2 times, right? So that is one of the reason. And then Kepler law is for the motion of planetary motion. T square is directly proportional to R cube, which is the time period square is directly proportional to the third power of radius of the planet, right? So this is in 11th class where in gravitational you study that T square is directly proportional to R cube. So that is the distance and T is the time. T is the time of revolution. So that was the Kepler law of planetary motion. So you can see here Kepler law describe planetary motion such as elliptical orbit of planet and period distance relationship. So T square is directly proportional to R cube. So correctly going, you could have easily analyzed that this is none other than Wien's displacement law. So the correct answer for 96 is Wien's displacement law. Correct answer is Wien's displacement law. Is that clear to each and everyone? Quickly, guys. जल्दी से बताएंगे. Anyone having any doubt in question number 96? Clear? Okay, I hope everyone is understanding this. Anag, Anjali, Karuna, Lata, Mehti, Nital, whosoever is having this Oppo CPH2359, kindly rename it Preeti Shiksha Sonika Vedhe. Right. Let's move to the next question. Paper was not that much tough, but the problem is either you read the question in hurry and worry, or you don't consider it to be the readable. Right. So let's move forward and talk about the next question, which is question number 97. So the next question is 97. This is question is also very easy, right? This question is also very easy. So if you read that stability stuff, it have been clearly written in that table which is given in Gilbert, that it is the stability table, which under question number 97, under which condition the atmosphere will be more stable. So you know that when we have the stable atmosphere, then DLR is greater than ELR. This is the condition. A dry adiabatic lapse rate is more than environmental lapse rate, right? And under the stable condition, you also know that stable conditions are associated with inversion, and condition are stable either early morning or late night. Early morning or late night. And wind speed are very low. Wind speed is very low means 2 to 3 meter per second is a sufficient wind speed, right? But let me remind you very clearly, right? Let me remind you very clearly, and they are saying what? They are saying you a hint. They are saying you a hint. They are writing a note that surface wind speed is measured at 10 meter above the ground. Right? On ground नहीं कह रहे हैं, 10 meter above the ground with the help of anemometer. So 10 meter above the ground, if the wind speed is 2 to 3 meter per second and the sky is clear, the night is clear, then you will definitely have most stable atmosphere. These three options were having a fight, actually. These three options were in fight, 1, 2, and 3. But how we eliminated them, that I will tell you. Everywhere the speed is same, 2 to 3 meter per second, 2 to 3 meter per second. But cloudy night will not result into more stable condition. Cloudy summer day will not result because daytime में तो stability होती नहीं है, right? It will be stable either early morning or late night. So clear night, it should be very clear, should not have any cloud because cloud also impact the stability in phenomena. So that's why we have chosen third as the correct answer among these because that is the most suitable option. Wind speed should be 2 to 3 meter per second and it should be a clear night. Then only you say that it is most stable, right? Clear है सबको? Rest of the conditions I have explained below. That what is atmospheric stability, stable atmosphere, unstable atmosphere, neutral, right? Temperature profile, inversion, why it is happened, cloud sky, what it happened, clear sky, what it happened, right? So you should be having a clear cut sky, then only you can say that in the night time it is most stable. Is that clear for 97? The explanation I have attached, and this topic we have covered in very detail in climate change and air. So there is no point, right? So this was 97. Let's move further. and talk about more questions. भाई क्लाउड कवर का इफेक्ट आपको बताया तो है, अगर क्लाउड कवर होगा तो कैसे आप कहोगे स्टेबल है? क्लाउड की मूवमेंट्स भी तो रहेगी वहां पे। क्लाउड रहेगा तो स्टेबल हो ही नहीं सकता ना, क्लाउड के रहते स्टेबल हो ही नहीं सकता। क्लाउड कब रहेंगे आपको क्या लगता है? या तो क्लाउड तब रहेंगे जब सोलर इंसुलेशन आपका जीरो हो जाएगा, ठीक है? तो सोलर इंसुलेशन अगर आप कम करेंगे तो उसका इम्पैक्ट ऑटोमेटिकली पड़ेगा। तो क्लाउडी कंडीशन में कभी भी नहीं होता है, जो स्टेबिलिटी टेबल दी हुई है और डिस्पर्शन फैक्टर की टेबल एक गिलबर्ट में वहां देख सकते हैं हम, क्लाउडी कंडीशन में मोस्ट स्टेबल हो ही नहीं सकता है कभी भी, राइट? क्योंकि हीट लॉस में इश्यू आएगा, मेंशन किया हुआ देखो यहाँ पे हमने, मैं दिखा देता हूँ आपको। जस्ट अ मिनट, ये देखिए, वाई वी से कि क्लियर नाइट होनी चाहिए तभी अच्छा है हमारे लिए, दैट इज द रीजन। Allow for maximum terrestrial radiation to lose from the surface to space, and this leads to a rapid cooling of the ground and the air directly above it, often resulting in strong surface inversion and very stable condition। तो surface inversion के लिए जरूरी है कि क्लाउड क्लियरेज ना हो। आपके फील कराने से नहीं है जी, आपके फील कराने से नहीं है, इट शुड एक्चुअली हैपन। आप घर में क्या फील कर रहे हैं उससे मतलब नहीं है। क्लाउडी कंडीशन तो बारिश से पहले भी होती है, आंधी तूफान से पहले भी होती ठीक है ना, है ना? आंधी तूफान से पहले भी होती है, ठीक है? ठीक है, वेरी स्टेबल पूछा है उसमें। हाँ, तो वो आप फील नहीं कर सकते क्योंकि ये टेम्परेरी मोमेंट्स होते हैं, जो स्टेबिलिटी है, ये अनस्टेबिलिटी है, टेम्परेरी मोमेंट्स है एटमॉस्फेयर में, हमेशा नहीं रहती है। एवरी सेकंड दे चेंजेस, ठीक है? एवरी सेकंड दे चेंजेस, राइट? सरफेस इन्वर्जन तभी होगा ना जब खुला रहेगा, राइट? आपको लिख के दिया है हमने, चिंता मत करो। नेक्स्ट क्वेश्चन, ये तो मैंने कल पढ़ाया है, दिस वी हैव डन यस्टरडे, this exactly we have done yesterday। what is tidal range? half of rho g a r square। तो टाइडल रेंज मैंने कल ही पढ़ाया था आपको ये क्वेश्चन, ठीक है? तो कल मैं पढ़ा रहा था क्लास में, तो मैंने बताया था आपको 98 क्वेश्चन टाइडल रेंज क्या होती है, मैंने इस तरह का एक डायग्राम ड्रॉ किया था, जो कि आपका है भी, दिया भी हुआ है। तो जब आपकी वेव आएगी, तो ये जो आपकी हाइट है बिटवीन द लो टाइड एंड द हाई टाइड, लो टाइड एंड द हाई टाइड, दिस इज योर टाइडल रेंज, राइट? तो हाई टाइड वाले का भी मीन पोजीशन है, लो टाइड वाले का भी मीन पोजीशन है, दैट्स व्हाई वी कॉल इट एज टाइडल रेंज। तो टाइडल रेंज, right? So that's why we say tidal range, and it is clear cut that tidal range is what? So it is the difference between, as I told you yesterday with the help of the diagram in the tidal energy class, I told you it is the difference in water level between the two consecutive high and low tide। तो दोनों consecutive एक के बाद एक हाई एक लो, दोनों के वाटर लेवल का, हाई टाइड और लो टाइड के बीच का जो डिफरेंस है, उसको हम कहते हैं टाइडल रेंज। और फार्मूला भी मैंने आपको बताया था कि द टाइडल पावर इज इक्वल टू हाफ ऑफ रो ए जी एच स्क्वायर, वेयर एच इज द टाइडल हाइट या टाइडल रेंज, कोई आर भी लिख देता है, मर्जी है। तो इस पे तो बहुत सारा काम हमने पहले ही करा है, राइट? और अभी भी करेंगे जब लास्ट में टेक्निकल सेशन पढ़ेंगे, है ना? तो वो आपको ध्यान रखना है कि टाइडल रेंज क्या होती है और कहाँ से हम मेजर करते हैं, ठीक है? अब इसमें कुछ टर्म्स भी हैं और जो आप देख सकते हैं, ऊपर तो ऑप्शन है, ठीक है? लेकिन टाइडल रेंज एक्चुअली में क्या होती है? इट इज अ वर्टिकल डिस्टेंस बिटवीन, टाइडल रेंज वर्टिकल डिफरेंस इन हाइट बिटवीन हाई टाइड एंड नेक्स्ट लो टाइड, दोनों साथ साथ होने चाहिए। एक हाई एक लो है, उनके बीच का हाइट का जो डिफरेंस है। और यहाँ पे हमने मेंशन भी किया है, tidal range is the fundamental concept of oceanography. It refers to the vertical distance between the highest water level reached during the high tide and the lowest water level reached during the low tide in a spatial location and tidal cycle. Mean sea level भी हमने बताया था is the reference point representing the average height of the sea surface over a long period. Tidal period भी है एक, this refers to a time to take the full tide cycle from one high tide to the next low tide, right? That we will study in wave energy actually. टाइम पीरियड भी होता है, बट ये बहुत सिंपल क्वेश्चन था टाइडल रेंज की, डिफरेंस बिटवीन द वाटर लेवल टू कंसेक्यूटिव हाई टाइड या लो टाइड। करेक्ट ऑप्शन फॉर 98 विल बी 4। 98 will be 4, right? So the question number 98 is 4. Now let's move to question number 99. Yeah, this was the question of this paper, which actually was new, completely new as far as the exam is concerned, but it have been asked in chemical energy in GATE multiple times, right? It have been asked in all other exams, but here it was a pretty new question if you talk to me. But let's have a look, and this belongs to coal, and coal is the king. Yesterday I told you that coal is having a lot of attention from the examiner nowadays. कोल को तो आपको तवज्जो देनी पड़ेगी, आप छोड़ नहीं सकते उसको, राइट? है ना? तो यहाँ पे देख लेते हैं फटाफट से। So we can see here that question number 99 says, इन द एनालिसिस ऑफ कोल, कल भी हमने बात की थी कि कोल के दो तरह के एनालिसिस होते हैं, एक प्रॉक्सिमेट और एक अल्टीमेट। प्रॉक्सिमेट में आप फिक्स कार्बन और ऐश कंटेंट, और अल्टीमेट में कार्बन, हाइड्रोजन, ऑक्सीजन, नाइट्रोजन, सल्फर, ऐश, राइट, ये सारे करते हैं। तो व्हेन द रेशियो ऑफ द ऑल इनऑर्गेनिक बेसिस कंपाउंड इन द ऐश टू द सम ऑफ ऑल एसिडिक कंपोनेंट इन द ऐश, तो ये रेशियो आपको कैलकुलेट करने को कह रहा है कि इनऑर्गेनिक सब्सटेंस जो बेस कंपाउंड्स होते हैं, राइट, जैसे जितनी मेटल ऑक्साइड है, कैल्शियम, मैग्नीशियम, सोडियम, पोटेशियम, आयरन, ये सब बेसिक होती है क्योंकि मेटल ऑक्साइड्स आर बेसिक इन नेचर। तो जितने भी एसिडिक कंपोनेंट है जैसे Al2O3 हुआ, SiO2 हुआ, राइट, मल्टीप्लाइड बाय द परसेंटेज ऑफ सोडियम ऑक्साइड, Na2O से मल्टीप्लाई करेंगे, उसको क्या कहते हैं, राइट? ये डेफिनेशन ही पूछी है एक्चुअली में। तो नाउ लेट्स हैव अ लुक। वैसे कहते तो उसको फॉलिंग फैक्टर है, बट हम समझते हैं पहले कि एक्चुअली हमें चीजें देखनी कैसे है, कि एल्कली इंडेक्स क्या होता है, फॉलिंग फैक्टर क्या होता है, बेस टू एसिड रेशियो क्या होता है, स्लैगिंग फैक्टर क्या होता है ना? तो लेट्स टॉक अबाउट देम, दैट विल हेल्प अस आउट इन अंडरस्टैंडिंग मोर थिंग्स। और इसको अच्छे से पढ़ के जाना है, इससे दोबारा क्वेश्चन मिल सकता है क्योंकि ये नई चीज है। तो द फर्स्ट ऑप्शन इज फॉलिंग फैक्टर इन कोल एनालिसिस। ये क्या है फॉलिंग फैक्टर, राइट? The falling factor is an important parameter in coal analysis, particularly related to how ash forming material in coal affect the heat transfer surface in the boiler. तो जो बॉयलर होते हैं उनके अंदर जो हीट ट्रांसफर होता है when you burn the coal, तो जो ऐश बनाने वाला, so the material which basically forms ash in the coal, right, how they are affecting the heat transfer in the boiler. That is the basic logic of calculating falling factor, right? Because more the ash formation, lesser will be the stuff, and that will create problem. If you talk about falling factor, the falling factor is an index that predicts that the tendency of ash from the coal combustion to form sticky low melting deposit falling. So it will definitely going to calculate that what is the tendency of the ash to form a falling stuff. Falling is basically low melting deposit which sticks into the blast furnace on boiler tubes and other heat transfer surface, so that it will create a problem in transferring the heat. How it is measured, that is also one of the question. So now we can see that how it is measured. It is typically calculated using the ratio base alkali oxide to acidic oxide in the ash of coal. तो फॉलिंग फैक्टर का एक फार्मूला होता है गाइस, दैट फॉलिंग फैक्टर इज इक्वल टू जितने भी आपके बेसिक है, बिकॉज मेटल ऑक्साइड्स आर बेसिक, सो आयरन ऑक्साइड, कैल्शियम ऑक्साइड, मैग्नीशियम, सोडियम, पोटेशियम, to that of the acidic component like SiO2 and Al2O3, and then it is multiplied with sodium oxide. क्वेश्चन में ये आपसे पूछा था कि मल्टीप्लाई विथ सोडियम ऑक्साइड ऑल्सो है, आप देख सकते हैं वहां पे लिखा हुआ है, ठीक है ना? मल्टीप्लाइड बाय द परसेंटेज ऑफ द सोडियम ऑक्साइड. So that is basically what you call as falling factor. So this was the one of the thing which was the correct answer, what actually falling factor is. Then they have asked about, and they have mentioned here also, and the application type. High falling factor more than 0.6 indicate high falling tendency, more likely to form sticky deposits, right? Low falling factor less than 0.3 indicate low falling tendency, cleaner combustion surfaces. So उनका logic भी है कि अगर falling factor is high, what will happen? Low, what will happen? So it matters in transfer of heat cases, heat transfer efficiency को. So falling reduces the heat transfer efficiency and causes overheating and leads to maintenance issue in boiler, right? And selecting suitable coal and designing the boiler. This it will help you to doing that. Next up is alkali index. Alkali index क्या होता है, right? तो alkali index का भी आपको ध्यान रखना है because it is also a new term can puzzle you again. So when you talk about alkali index in coal, क्योंकि कल हम एनर्जी पढ़ रहे थे तो कोल के बारे में पता होनी चाहिए डिटेल. So the alkali index is calculated value that estimate the amount of alkali metals, sodium, potassium, and oxides delivered to the boiler per ton of carbon burn. For each ton of carbon burn, how much we supply these oxides to the boiler. That is alkali index, and it is crucial for evaluating falling and slagging potential of coal. Right, right. So then, what it measure? It measures sodium oxide, potassium oxide, and ash content of the coal, and the formula is alkali oxide is equal to sodium oxide into potassium plus potassium oxide into heating value of coal. What is the calorific value actually, right? So this way also you can calculate, or the second method is sum of inorganic bases to sum of acid and percentage of sodium oxide. So alkali index can also be calculated in this manner, right? But it is not in ash, only percentage of sodium, and iron is not included here, right? Right. So this you have to keep in mind. Better we choose this formula for alkali index, because other one is quietly overlapping with falling index. Then we have, and they have given the values, right? How we can judge the falling risk. If it is alkali index comes out to less than 0.24 low, 0.24 to 34 moderate, and more than 0.34 high. इसको अच्छे से guys you should read, because might be it can create another question for you. It is my expectation. Base to acid ratio is simple oxides of basic to that of acidic, and here they have given that slagging tendency will be how much, so you should read that also, right? And slagging factor you can calculate, like slagging factor is having a formula like iron oxide, calcium, magnesium, sodium, potassium divided by silicon oxide. That is the slagging factor, which is here. Like these kind of questions generally comes in GATE, environmental science and engineering, and GATE, metallurgical engineering and chemical engineering. I don't know why teacher have put up this here. Might be just to show off that we can put such kind of question also. So just do read it well, because it is a sort of not that much a relevant question from the perspective of environment. Rather, it is a metallurgical science question, right? Or M.Tech and B.Tech energy sciences, not this, right? So here the first thing which they ask is the falling factor, and which is the correct answer. Actually, they ask the formula, what actually the falling factor is. So falling factor basically indicate the indicated in the definition, and I told you that. Now coming to next question, which is question number 100. I guess it is clear to each and everyone, the 99, how we have to read. And just don't go much deeper into this. Just memorize some formula and what is slagging and what is falling, right? What is alkali index? You should know the physical meaning. Don't go into these values, because they are not going to ask every time that much deep, right? This question is very simple and directly taken from booklet, the question number 100, right? So this is a very simple question. Concentration of dissolved oxygen in water is determined by. So when I was teaching you that thing, that pressure outside the stream, inside the stream, influx, outflux, we have talked about everything there. So it will, the movement of oxygen is regulated by fixed law. So it will depends upon turbulence. Yes, it will depends upon temperature. We know that DO is inversely proportional to temperature. That we know very well, that DO is inversely proportional to temperature as per the solubility of gases. So more temperature, less DO, less temperature, more DO. Then concentration of in the oxygen in atmosphere will also matter. Activity of organism will also matter, right? But genetic diversity is one factor which I don't think is going to contribute into the concentration of dissolved oxygen. Right. More the activity of organism, more is the solubility, because bubbling ज़्यादा होगा, surface area ज़्यादा involved होगा. So except this genetic diversity, all other factors are important when you have to see the concentration of dissolved oxygen. And we have mentioned the same, that why they do so and why it is. So like first factor, turbulence, increase the dissolution of oxygen. Temperature, high temperature, low solubility, low temperature, more solubility. Concentration of oxygen, yes, that do. Activity of organism affects, but last option, which is species, that do not affect. So except that option, everyone is there. So we have A, B, C, D as correct answer, and which is given in only first option. And this is a good question, direct lines of Gilbert, and multiple time we have discussed it with our like topic also in water pollution. Is that clear to each and everyone? Jaldi se bataiye. Is it clear to each and everyone? Question number 100. Okay. Then if we are clear, we are done for today's quota, and we expect that you will read these questions very well. That's why we give only 10 questions a day. I'm not giving overburden to you. Same we expect whatever ma'am discussed in paper 1, you should have read. And the records are also available. If you skip the class, then there is a possibility that you can listen and get back to it. We expect that you get back to these things and study them well, because my expectation is out of these 100 questions, you might get 10, 12 hinted question in the upcoming exam, which will basically spark a good lead. 20 marks is not a bad lead. 20 marks is a very good lead, right? If you get 10, 15 question on similar theme or related theme, that will definitely save a lot of time for you. And it is the habit of NTA to get into such kind of things, because they generally put the paper in front for last 5 years while making the paper. So their mind revolved around the same concept. So we expect that it is there. So with this, we will stop here. Tomorrow we will join with more questions, right? That's why I'm taking few question a day, so that you can digest them in a relaxed mode. 10 question is nothing. Reading 10 question solution is nothing. So we expect everyone to digest them very well in the slow motion, so that you can utilize them at maximum. Same goes for paper 1 also. We have released both the solution, and it have been given to you for the same purpose कि आप slowly digest करेंगे. Okay, then see you guys at 7 for the class of energy. Till then, you enjoy. Take care.